I'm going to explain how to calculate the determinant of a square matrix. Now, a determinant is simply a value which is associated with a square matrix. For 2 by 2 matrices, this is quite easy to calculate. So here we have the definition of a 2 by 2 determinant. So the notation is det, which is simply short for determinant, of this 2 by 2 matrix A, B, C, D. This is equal to A multiplied by D minus B multiplied by C. So it's the elements on the main diagonal minus the product of the other two elements. So if we show this by way of an example, so here we have the 2 by 2 matrix A. So the determinant, now this is an alternate notation where we just use vertical bars either side of the matrix. So if we multiply the elements on the main diagonal, so we have 1 multiplied by 2, and from that we subtract the product of the other two elements. So in this case we simply have 2 minus 0, giving us a determinant of 2. Now, for determinants of larger matrices, we first need to calculate what are called cofactors. Now, a cofactor of an element, aij, so that's the element in the ith row and jth column, is the determinant formed by removing row I and column j from A. So we end up with a matrix which is n minus 1 by n minus 1, and then we multiply that determinant by minus 1 to the power of I plus j. So by way of example, here we have a 3 by 3 matrix, and we're going to calculate the cofactor C21. So that's the cofactor of this element 2 here. So what we do is we block off row 2 and column 1. So here we can see we blocked off row 2, column 1. We're left with a 2 by 2 matrix. We calculate the determinant of that 2 by 2 matrix and multiply it by minus 1 to the power of 2 plus 1, because second row, first column. Okay, so we end up with this determinant, and multiply the main diagonal elements together, subtract the product of the other two elements. So the determinant is equal to minus 20, but of course we're multiplying by minus 1, so this cofactor is equal to 20. So to calculate the determinant of an n by n matrix, we can choose either to expand along a row or column. So this is how it's defined. So we have this summation here. So the determinant is a sum of elements on the ith row kth column of A multiplied by their cofactors. Now k is simply a number between 1 and n inclusive. Now that could be any row or any column of A. So as you can see here, the first summation, this is where k represents a column, and the second summation is where k represents a row. Okay, so I'm going to show this by way of an example. So this is the same 3 by 3 matrix as before, and we're going to set k to be equal to 1, and we're going to expand across the first row. Okay, and then I've highlighted the elements on the first row here. Okay, so we have A11, which is 1, multiplied by the cofactor C11, plus A12, which is 0, multiplied by the cofactor C12, and A13, which is 4, multiplied by the cofactor C13. Okay, so if we remember to block off the rows and columns, so the cofactor of 1 is we block off the first column and the first row, and we're left with 5, 6, 5, 2. The cofactor of 0, we block off the first row, second column, so we're left with the elements 5, 6, 4, 2. And finally for 4, we block off the first row, third column, and we're left with the elements 2, 5, 4, 5. Okay, remembering that where we have the row number plus the column number is an odd number, we're going to have change the sign to a negative. Okay, so if we evaluate those determinants, so the same way as before, multiply the main diagonal elements together, subtract the product of the other two elements, and if we add all those together, we get a determinant of minus 60. Now, I mentioned before that it doesn't matter whether we choose any row or column of A, so I'm going to do the same calculation of the determinant, but this time using the first column. So I've highlighted the elements on the first column here. So we proceed similar as before. So A11 times C11 plus A21 times C21 plus A31 times C31. Okay, so if we block off our rows and columns, for C11 we have the 5, 6, 5, 2 as before. For C21 we block off second row, first column, as we get 0, 4, 5 and 2. And for C31 we block off the third row, first column, so we have 0, 4, 5 and 6. Okay, so if we calculate those 2 by 2 determinants, add them all together, and we also get minus 60. So this shows it doesn't matter which row or column you expand along in order to calculate the determinant. A useful trick here is to try and use a row or column with most zeros in, because this cuts down on the amount of work you have to do.